In this video, we'll be talking about triangle congruences, and first let's define congruent triangles. So two triangles are congruent if and only if they are essentially the same triangle, which means that if you can pick up one triangle and rotate it in any way and place it on top of the other triangle, it'd be a perfect fit, basically. That means all sides are equal, all angles are equal. That's different from similar triangles in that similar triangles only require that all angles are equal. The sides can be multiples of the other sides. But it turns out there's a couple of theorems for congruent triangles that we can use to prove congruence. So I've drawn them out here. Let's just go over them. So first one, this one, side, side, side. That means that the corresponding sides of the two triangles are equal. And these markings mean if there's one marking, that means that it's the same length as on this one, the other marking. And this side is the same as this side is the same as this side. So in this theorem proves that the two triangles are congruent. Now this theorem is the first one that involves angles, SAS, which is side, angle, side. And these theorems are usually written in a very logical order so that you can follow it. So here's the first side. Here's the angle, here's the side. And even though this triangle is upside down, if we flipped it over and we translated it in space, we can see that this side matches with this side, this angle matches with this angle, and this side matches with this side, which proves that they are congruent. Next one's up here. Angle, side, angle. So we see that these angles are the same in this triangle, this side is the same, and this angle is the same. So this angle is denoted by two markings, which means it's the same as this one. And that proves that it's congruent. Next one is angle, angle, side. So we find an angle first. So this angle is congruent in both. This angle is congruent in both. And this side, this side right here is congruent in both, which proves that there's congruent triangles. And the last one we're going to talk about is hypotenuse leg. This one only works for right triangles, and in right triangles you have to prove that the hypotenuse is going to be equal in both, and also one leg of the right triangle is equal in both. And that proves that the last leg is also equal, and that can be done by Pythagorean theorem. But basically any of these, if you can find them in a triangle, prove that the two triangles are congruent, and that will help you in a lot of math problems, because knowing they're congruent means that, let's say for example in the SAS case, you can prove they're congruent by SAS. Then you also know that this angle is equal to this angle and this side is equal to this side, so you can make inferences that you couldn't otherwise make.